Kuzuzangpo. Welcome to Bhutan e-learning program. I am Balbadur Gurung from Losling Middle Secondary School, Thimphu. And today I'm here for Key Stage 4, particularly for classes 9 and 10. And today we will be discussing on carbon cycle and nitrogen cycle. So before we really go into what is carbon cycle and nitrogen cycle, let's look at the objectives. So we will be achieving the following objectives. The first one, we will look at the definition of green chemistry. We will also try explaining nitrogen and carbon cycles. And finally, we'll also look at the importance of nitrogen cycle and carbon cycle. Nitrogen cycle and carbon cycle play an important role in maintaining the balance in nature. However, due to excessive human activities and developmental activity that is going around, have disturbed the balance in nature. So this is where the green chemistry plays important role. So before that, let's see what is green chemistry. So green chemistry is not a chemistry that is green. So green chemistry, it is a branch of chemistry that deals with different processes and methods to reduce or eliminate the use or generation of hazardous substances. So this is what we call green chemistry. This chemistry will give us different methods on how to eliminate the hazardous substances produced due to human activities. And green chemistry is also known as sustainable chemistry because the green chemistry has different innovative scientific methods or solutions which can actually reduce the environmental problems. And nitrogen cycle and carbon cycle, as I was telling you, are two important processes that help maintain balance in nature. So now let's look at nitrogen cycle. Why is nitrogen cycle important? Nitrogen is very, very necessary constituent that all living matter should have. It is essential for the growth of plants and animals. So we need nitrogen in the form of protein. That protein is actually going to help us grow and develop ourselves. However, although there are about 78% of nitrogen in the atmosphere, we cannot directly use this nitrogen from the atmosphere, meaning we cannot assimilate the atmospheric nitrogen directly. So in order to actually get the nitrogen, animals will have to depend to the plant, and plant in turn will have to depend on the nitrogen compounds that are present in the soil. Thus, nitrogen forms a permanent link. So there is a permanent link between animal and the plant kingdom, meaning we depend to one another for nitrogen. And this process is actually maintained in the form of nitrogen cycle. So I am going to explain you what is nitrogen cycle, how nitrogen cycle actually works. So let's see. So let's say we have atmospheric nitrogen, that is N2, and as I already told you, 78% of the atmosphere or the air is actually nitrogen. Although there is huge amount of nitrogen, we cannot directly consume, meaning plant or the animal cannot directly use that nitrogen. So for that, how actually plant fix the nitrogen in the soil? So there are actually three methods of nitrogen fixation. So let's look at the first method. So first method is the nitrogen fixation by lightning. So when there is lightning, what happens is you have atmospheric nitrogen, that is N2, and 2 atoms of nitrogen. So you can see they are triple bond. Since the bond between this 2 atoms of nitrogen, it is triple bond, so this one is very, very stable molecule. And at ordinary condition, at ordinary temperature and pressure, so this nitrogen will not combine with water. But what happens is, when there is lightning, temperature becomes extremely high. The temperature becomes extremely high, and that is the time the nitrogen, atmospheric nitrogen, will combine with oxygen and it forms nitric oxide. And again, this nitric oxide further combines with oxygen to form nitrogen dioxide. And this nitrogen dioxide will be in the atmosphere, and when the rain comes, when it rains, then this nitrogen dioxide is going to combine with water to form nitric acid. So it forms nitric acid, and as you can see there, so when it rains, along with the rain, this nitric acid will also fall down together in the form of acid rain. So this is how actually formation of acid rain takes place. And when this acid rain comes down, this NO3 is going to decompose. This NO3, that is nitric acid, is going to decompose. Decompose in chemistry means to break down. It is going to break down into hydrogen ion and nitrate ion. And nitrate ion is very, very soluble in water. And this is where the plant will absorb this nitrogen through their roots. So you can also see there, so it is going to break down into hydrogen ions and nitrate ions. And nitrogen ion is the one, nitrate ion is the one that the plant is going to absorb. That is one way of actually nitrogen fixation. So next is nitrogen fixation through nitrogen fixing bacteria. So the plants like leguminous plants like beans, pea, dal, their actually root noodles will have the bacteria which is capable of fixing the atmospheric nitrogen to the soil. So you can see this bacteria, and the name of this bacteria we call is rhizobium, and this rhizobium can actually convert the atmospheric nitrogen into the nitrogen, other forms of nitrogen that can be absorbed by the plant. So this is one way of fixing the nitrogen. And another way of fixing the nitrogen is by blue-green algae. Blue-green algae can also fix the atmospheric nitrogen. So now, once this atmospheric nitrogen is actually converted into ammonia by nitrogen fixing bacteria, so again there is another bacteria which we call it nitrifying bacteria. So this nitrifying bacteria is going to further convert ammonium or ammonia into nitrate, because nitrate is the compound, nitrate is the ion which plant can fairly absorb through their roots. So this is the most soluble form of nitrogen in the form of nitrate, and it can be very well absorbed by the plant. Okay? So that is why nitrogen should be converted in the form of nitrate form. And once it is converted into nitrate, so it is going to be absorbed by the roots of the plant. So nitrate will be assimilated by the plants through their root, and this nitrate will be converted into plant protein. And as the animals and we human beings actually take the food that is prepared by plants, and that plant protein will get converted into animal protein, and that is how the protein will help us grow and develop our body. And animals and we human being actually excretes out the waste product. So this is the waste product you can see there. So we excrete out, we actually give out the waste product, and our waste product also contain nitrogen substances, and we have another bacteria, a decomposing bacteria that is capable of breaking down the waste product into again ammonia, and this process is known as ammonification. So what is happening here? The waste product that is released from the animal is broken down and converted into ammonium ion. And again you have nitrifying bacteria will convert ammonium ion into nitrate. Nitrate will be assimilated by the plants. Plants prepares that into plant protein. Again we take it, it develops into animal protein. Animal protein will help us grow, develop. Again excretion is there. So this is how the small cycle will actually take place. And all the nitrate that is under the soil will not be assimilated by the plants. Some of this nitrate, we have another bacteria which is denitrification bacteria. This bacteria will convert this nitrate back to nitrogen. This bacteria is going to convert the nitrate back to nitrogen. Actually the process happens this way. You have the nitrate, nitrate will be converted into nitrite, then nitrite will be converted into nitric oxide, then this nitric oxide will be converted into dinitrogen oxide, and back it will be converted into nitrogen, meaning from where this nitrate compound has come? It has come from the atmosphere, and at last it is again going back to the atmosphere. So this is how the cycle keeps on repeating. And when you disturb the system, when we disturb the nitrogen cycle, what happens is the plant will not be able to absorb enough nitrogen for their growth. So that is the time our farmer will start using chemical fertilizers which contains nitrogen. And when we actually sprinkle chemical fertilizers, what happens is when there is a rain, so chemical fertilizers will be washed away and it will be taken to the pond, lakes, ocean. So now your pond, oceans or lakes will be full of chemical fertilizers. So that is the time the algal bloom will take place. The algal growth will take place because of excessive amount of fertilizers that is inside the water. And when algae blooms, what happens? The surface of the water will be covered by algae, and that algae is going to protect the sunlight that is coming in. Then there will be aquatic plants. Aquatic plants mean the plants that grow under the water. There will be aquatic plants, and these aquatic plants will not be able to prepare the food. Why is aquatic plant not able to prepare the food? Because there is no sunlight. Why there is no sunlight? It is blocked by the algal bloom. And when there is no photosynthesis taking place, so production of oxygen will be less. And the time aquatic beings like fish, octopus and different living organisms that are inside the water will suffocate from lack of oxygen. And this process is known as eutrophication. Let's look at carbon cycle. Carbon is building element of living organism. All living organisms are actually made up of carbon. And carbon in the form of carbon dioxide is present in the atmosphere. So we have carbon even in the atmosphere, but it is in the form of carbon dioxide. And if you just look at the percentage composition of carbon dioxide, it's very, very less, just 0.03%. Although the amount of carbon dioxide in the atmosphere is very, very minimal, the role it plays is very significant. And the plant uses atmospheric carbon dioxide for photosynthesis. Photosynthesis is one important process which actually plant prepares food, and that food is used by different living organisms. This carbohydrate fats that is prepared during photosynthesis are actually utilized by consumers like us and even other animals. Both producers and consumers, producer here is the plant because the plant produces the food, and consumers are the animal. We cannot produce our own food. We depend on plants for food. What happens here is we take in the food prepared by the plant, and in return we give the carbon dioxide back to the atmosphere through respiration and also other means. So what are the other means we'll discuss in later part of my presentation. And the balance of carbon in the atmosphere is maintained by carbon cycle. So you must be thinking, plant is constantly using the carbon dioxide during the photosynthesis, and the carbon dioxide that is in the atmosphere must get finished. It should get exhausted. Why is that not happening? Because it is well maintained by carbon cycle. So let's look here. You have carbon dioxide in the atmosphere, and as I told you, during photosynthesis, so you know you have already studied about photosynthesis in your lower classes. During photosynthesis, in presence of sunlight and chlorophyll, carbon dioxide from the atmosphere is absorbed by the plant, and in turn it gives us food. And this food is actually taken by animals, and once this food is broken down into smaller pieces, so what we do there, once the food is taken in, this food should be broken down into smaller pieces in presence of oxygen. So that is what we call respiration. So during respiration we give the carbon dioxide back. So there is a small cycle taking place. That is how the carbon cycle actually remains balanced. Then other way is just like animals, plant also respire. So even plant respires to give carbon dioxide. Then other way of giving back the carbon dioxide to the atmosphere is when the living things actually die. When we die, there is a decomposing organism. Those decomposing organisms will help decompose the dead remains of the plants. We will be broken down into smaller pieces. This bacteria will help us, help the dead remains of the plant to break down into smaller pieces. Then what happens is, slowly over millions of years, this dead remain of the plant is going to be converted into fossil fuels. And this fossil fuel, what we do? Fossil fuels like we have petrol, then we have diesel, we have kerosene. Those fossil fuels, actually what we do is we use in the factory, we use at our home, and again when you burn, combustion means burning. So when we burn, it is given back to the atmosphere. So this is how the carbon cycle actually maintains the balance in carbon dioxide in the atmosphere. But if you disturb this, what happens? If you cut down all the trees, then there will be very less trees to absorb the carbon dioxide from the atmosphere. So therefore, instead of cutting down the trees, it is important that we plant more trees. To summarize this whole concept of carbon cycle, so there are actually 4 processes. Photosynthesis. So during photosynthesis, carbon dioxide is being absorbed and plant prepares the food. Then the food that we eat, what happens during respiration? Carbon dioxide is given back to the atmosphere. Then once we die, our body decomposes and it forms a fossil fuel. Then that fossil fuels are burned, and again it is carbon dioxide is released to the atmosphere. So these are the 4 important processes that you need to understand in order to explain carbon cycle. So now let's look at the importance of carbon cycle. Carbon cycle maintains the global temperature of the earth. If there is no carbon dioxide in the atmosphere, then the temperature of the earth is going to be at extremes. It will be too cold at times and it will be too hot at times. So it is carbon dioxide that is helping the temperature to be maintained at certain degree. For example, what happens is, let's say that one is carbon dioxide, and when there is heat coming from the sun, there is a heat coming from the sun, and this carbon dioxide has very, very special property. It allows the heat to get in. The carbon dioxide allows the heat to get in, and however, it will not allow the infrared radiations, shortwave radiations. It is not going to allow it to go back. That is how the temperature of the earth is being maintained. That is how carbon dioxide actually maintains the temperature of the earth. And it is important to maintain the temperature of the earth, otherwise there will be no melting of snow. When there is no melting of snow, there will be no water flow in the river, isn't it? When the temperature is extremely cold, so the farming will not be possible. That is why it is important to maintain the temperature of certain degree Celsius, and this is what carbon dioxide actually does. If the concentration of the carbon dioxide increases, which means along with the increase in concentration of carbon dioxide, global temperature also increases. In atmosphere, we have certain amount of carbon dioxide, and those again we also have certain amount of carbon dioxide under the ground, which is in the form of carbonic acid, which is in the form of acid rain, and there is a balance between the concentration of carbon dioxide in the atmosphere and the concentration of the carbon dioxide under the ground. But when the carbon dioxide in the atmosphere increases, what happens is the carbon dioxide in the form of carbonic acid that is under the ground will dissolve with some more rocks containing limestone. Did you get? So when the carbonic acid dissolves in limestone, so concentration of the carbon dioxide under the ground becomes less. So that is how it will be able to absorb some more amount of carbon dioxide from the atmosphere, reducing the amount of carbon dioxide in the atmosphere. So that is how it maintains the balance of carbon dioxide in the atmosphere. Then another importance of carbon dioxide is fossil fuels. As I already told you, over the years, it will take millions and millions of years. Once this dead remain of the plant decompose, so it is going to form a fossil fuels like coal, we have petrol, diesel, kerosene, different natural gases. So this is one importance of carbon cycle. Another importance of carbon cycle is What is that? You just look there. That is a diamond, isn't it? So carbon cycle also helps in formation of diamond, but this one is very occasional because it needs very high temperature, high condition, and for example, if the condition is extremely high like volcano eruption, so that is the time, or that is where the diamond might form. Then another one is graphite. So graphite is a carbon that you see inside the pencil. So that is how actually graphite is formed. And here what you should know is this graphite is a conductor of heat and electricity. Other form of carbons are non-conductor. However, this graphite has one mobile electron. Mobile electron means the electron that can move freely. So graphite has one mobile electron. Due to that, graphite can conduct heat and electricity. Did you get? That is why it is not advisable to put the pencil inside the socket like that. It is not advisable to put your pencil inside the socket if your pencil is sharpened from both the ends. And here you should be responsible, and you can also pass this message to your younger brothers and sisters. Ask them not to do, because they will not know that the graphite inside the pencil is going to conduct electricity. So with this, I have come to the end. Before I really end my lesson, I have a home task for you. First one, explain carbon cycle using these 4 important processes: photosynthesis, respiration, decomposition, and combustion. The next task that I have for you is write down the importance of nitrogen cycle, and you also write down what are the implications of increased amount of carbon dioxide in the atmosphere. Lastly, graphite conducts electricity, but diamond does not. It is only the graphite from nonmetal that conducts electricity, but whereas other nonmetals will not conduct electricity. Why is that? Graphite conducts electricity, but diamond does not. Why? So with this, I have come to the end of my lesson. Thank you for being with me. Stay safe and have a great day. Thank you.